Okay, so today I want to talk about section 3.3, how derivatives affect the shape of a graph. This is like outline. The first one, I can talk about increasing, decreasing test. Second one is the first derivative test. Third one, concavity test. First one, inflection point. The fifth one, the second derivative test. I want to talk about 5 things today. First one, increasing and decreasing. This is the definition. So let I be a given interval. F is increasing on interval I. So if f of x2 is greater than f of x1 whenever x2 is greater than x1 on I. So what does it mean? This meaning is like this. Here, graph is like this. You can choose 2 points. This is x1. This is like x2. The x2 is greater than x1. What's the corresponding function value f of x1 and f of x2? This is f of x1. So this one is f of x2. What happens? F of x2 is greater than f of x1. So we have this one that we call increasing. Function f is decreasing on interval I if f of x2 is less than f of x1 whenever x2 is greater than x1 on interval I. So the same things. So what does it mean? Here, the graph is like this. You can choose 2 points. This is x1. This is like x2. So what happens? x2 is greater than x1. What's like the corresponding function values? Here, this one is f of x2. This one is f of x1. What's that? F of x1 is greater than f of x2. This is decreasing. So we have different direction like this. So one more. So what happens? We know the increasing from the function f is increasing from a to b, c to d, right? So what's that? You can draw tangent line. This is like the red one is tangent line. You choose this point. You can draw tangent line here. Tangent line like this. The tangent line. What's the slope of tangent line? The slope of tangent line is positive number. Same. You can see this point. You can draw tangent line. The slope of tangent line is also positive number. So how can you find slope of tangent line? Do you know? How can you find slope of tangent line? Could you write your answer on the chatting board, please? How can you find the slope of the tangent line? How can you find? That's right, the dy of dx, the delta y of delta x, you can take a limit. Delta x is going to 0, exactly dy of dx. This meaning is the f prime of x is a slope of tangent line is a positive. So we have this result. The function f is increasing. What's the conclusion? The derivative is positive. So we have it. The next one, decreasing from B to C. Here, the similar. You can choose point here, draw tangent line. You can choose this point, draw tangent line. So slope of this tangent line is less than 0. What's like a slope of tangent line? The similar. F prime of x. F prime of x is less than 0. The function is decreasing. So we have this result. F prime of x is less than 0. So from this example, we have increasing, decreasing test. So what happens? Let I be a given interval. If f prime of x is greater than 0 on interval I, then f is increasing on I. So if f prime of x is less than 0 on interval I, then f is decreasing on I. So we call increasing, decreasing test. What's like a key? F prime of x is positive, graph is increasing. F prime of x is less than 0, f is decreasing. This is like a whole idea, so like this. So next, the question. How to check function f has local maximum or local minimum? So this is the idea. So in this case, we have local maximum at C, is right? So what's that? Here, you can draw tangent line. What is f prime of C? What is f prime of C? Yes, slope is 0. So when do you have a local maximum here? The C is, you can choose x values on the left-hand side C. F prime of x is positive. What does it mean? Graph is increasing. You can choose point x on the right-hand side. F prime of x is negative, like graph is decreasing. This is the idea. So what does it mean? So I can draw the graph like this. Here, see here, you can check f prime of x. On the right-hand side, you can choose the right-hand side point. We have positive f prime. You can choose right-hand side, the negative f prime. What's it like f of x? F of x is increasing and decreasing. We have local maximum at C. So in this case, one more important thing, f prime of C equal to 0. So like this, right? This is one idea. So when do you have the local minimum? Very similar. We have a local minimum at C. Here, you can draw tangent line. What is f prime of C? F prime of C is, yes, 0 again. The same. So what happens on the left-hand side, right-hand side? The left-hand side, you can choose this point, draw a tangent line. The slope of tangent line is negative. You can choose a point on the right-hand side. The tangent line is like this, like increasing. F prime of x is positive. So we have this result. You choose a point C. You calculate f prime of C equal to 0. So one more. What happens f prime of x? You choose left-hand side, point on the left-hand side. So this is negative. Choose point on the right-hand side, like a positive. The f of x is, the negative slope is decreasing. Positive slope is increasing. The graph is decreasing and increasing. We have local minimum SC. This is the idea. So like this. So we don't have a local maximum, local minimum. So why here? So this is like f prime of C. The f prime of C is exactly 0. So this one is good. But f prime of x on the left-hand side, positive. The right-hand side, positive. Sign doesn't change. Doesn't change. In this case, the graph is increasing and increasing. So what does it mean? In this case, C is here. What is f prime? Positive, positive. Was it like a graph of f? Increasing, increasing. So we don't have a local maximum. We don't have a local minimum. Similarly, this one. Here, the f prime of C is 0. F prime of C equal to 0. So here, so you can choose point on the left-hand side. Slope is like negative. You can choose point on the right-hand side. Slope tangent line is the negative. So what does it mean? So this case is C is here. You can check f prime. Left-hand side, negative. Right-hand side, negative. What's the graph of f? Decreasing, decreasing. So we don't have a local maximum. We don't have a local minimum. But f prime of C is 0, like a critical number. So one more. Graph is like this. So like this. Here, we have local minimum at this point. So you can choose point on the left-hand side here, draw tangent line, y prime, f prime is like negative. You can choose a point on the right-hand side here, draw tangent line, slope tangent line is like a positive. We have local minimum. So what is f prime of c in this case? What is prime of c? Yep, does not exist. You're right. The thank you, guys. Does not exist. So what's it like C? That we call critical number. Critical number. What's that? C is here. Calculate f prime. The left-hand side negative. Right-hand side positive. Like positive. What's it like a graph of f? Graph of f is decreasing, increasing. We have local minimum. This is the idea. So what kind of which point? At which point does f have a local maximum, local minimum? Important thing is here, critical number. The critical number. What's like a critical number? F prime of c equal to 0 or f prime of c does not exist. We call critical number. This is like the idea. Here. The first derivative test. This is a method for finding local maximum and local minimum. So like this. Suppose that C is a critical number of a continuous function f. If f prime changes from positive to negative at C, f has a local maximum. If f prime changes from negative to positive at C, f has a local minimum at C. If f prime is positive to the left and the right on C, or negative to the left and right on C, f has no local maximum or minimum at C. So we don't have anything. So what does it mean? What's like case 1? Case 1 is graphs like this. Here, C, you can check f prime. What's C? This is a very important thing. C is critical number. What's like a critical number? F prime of C equal to 0 or f prime of C does not exist. It's like a critical number. You can check left-hand side. Left-hand side is positive. Right-hand side is negative. What's the graph of f? Graph of f is increasing and decreasing. So we have local, f of c is local maximum. Here, C is also critical number. You can choose x value on the left-hand side, negative. Right-hand side, positive. What is the graph of f? Decreasing and increasing. What does it mean? We have local minimum. This is local minimum. Another one, sign doesn't change. Here, the positive to the left and the right, or negative to the left and right. So what's that? No local maximum, no local minimum. This is like exact meaning. So like this. So example, suppose f prime of x is given x plus 3 cubed x minus 1 times x minus 5 square. Find the intervals on which f is increasing or decreasing. And find the local maximum and the local minimum. This is a problem. How can do that? So you can find critical number first. What's a critical number? F prime of x equal to 0 or f prime of x does not exist. f prime of x equal to 0. Which one equal to 0? This whole thing equal to 0. Like this. So we have it. This one exactly x plus 3 cube, x minus 1 times x minus 2 equal to 0. Was it like x? The x is here. This one equal to 0, x equals negative 3. X minus 1 equal to 0, x is 1. X minus 5 squared equal to 0, x is 5. We have 3 points. So f prime of x does not exist. So what's that? So this case is we don't have a denominator. The f prime of x is always exist. So we don't have a second part. So how can you sum the check increasing or decreasing? You have to use, this is a line. You can draw the line like this. You just only plot 3 points here. Negative 3. Here, 1. This one, 5. So far we have the 4 intervals. The less than negative 3, between negative 3 and the 1, between 1 and 5, the greater than 5. We have 4 intervals. Which interval has increasing graph? Which interval has decreasing graph? You can check f prime of x. F prime of x is positive or negative in the left-hand side. I want to choose one test number. So this test number is less than negative 3. So could you choose? You can choose. So which number do you want to choose? So this number is less than negative 3. Okay, good. Minus 4. You can choose minus 4. You can plug into here. Minus 4, and minus 4. The minus 4 plus 3 is negative 1. Negative 1 cube is negative 1. The negative 4 times negative 4 minus 1 is minus 5. So here, the 2 is even power. This is always positive. So like this, we have it. So what's that? Negative times negative is positive. It's the first one. You can choose the test number between the negative 3 and 1. You can choose which number do you want to choose between negative 3 and 1. Okay, good. You choose 0. You can choose 0. So what's that? Here. You can choose plug 0 into x. 0 and 0. You can choose like this. So what happens? So this one is 0 plus 3 is positive. 0 minus 1 is negative. Positive, negative, positive. What's that? This is negative. So like this. Next, you choose point between 1 and 5. Could you choose? What's the number? 1 and 5. Between 1 and 5. So what kind of number do you want to choose? Okay, good. 2. You can plug 2 into x. 2 into x. 2 plus 3 is positive. 2 minus 1 is positive. You don't check last one. Even power is always positive. This is positive. The next, choose a number on the right hand side. I want to choose like 6. You plug 6 into x. 6 into x. Positive, positive, positive. This is also positive. So what is f of x? F of x is here increasing, decreasing, increasing, increasing. This is like idea for solving this problem. So we have this result. So like this. So what happens? So function f is increasing on this interval. Increasing. This is like increasing, increasing, increasing. What's that? Interval is 0, 3, sorry, minus infinity to 3. And second one, 1, 2, 5, another one, 5 to infinity. So like this. What's like decreasing? Decreasing on only one interval, negative 3 to 1. This is like a whole idea. So we have like this. The next tip. So do you have a local maximum? Do we have a local maximum? Yes. And minus 3, this graph is the increasing and decreasing here, local maximum. So local maximum is f of minus 3. So we have a local minimum. Yes, 1. The graph is decreasing, increasing at 1. And 1, local minimum. So f of minus 3 is local maximum. F of 1 is local minimum. This is the whole idea for solving this problem. The next tip. This is definition. The graph of f lies above all of its tangents on an interval I. Then it is called concave upward on I. If the graph of f lies below all of its tangents on an interval I, then it is called concave downward on interval I. So this is concave upward. So it's right. You can choose point here. Point. You can draw tangent line. So what happens? All points on the curve is exactly above tangent line. Like this one is like above tangent line, right? So you can choose this point, same. You can draw tangent lines like this. This point is above tangent line. Okay, this is concave upward. So one more. This is concave upward. So what kind of property do we have it? You can think about f prime of x. This is f prime of x is exactly what's the prime of x? Here. So f prime of x is was it like a slope tangent line? The slope tangent line at this point, the f prime of x is, I think, the 1/2, like this. You choose this point. F prime of x is like steeper. This is like f prime of x is like 2. You can choose this point. This is a tangent line. The slope tangent line is f prime of x is like 3. What does it mean? The x value increasing like this. What happens f prime of x? 1/2, 2, 3. F prime is increasing. So I want to use increasing test. What is the increasing test? F prime of x is positive. What's that? The function f is increasing. This is like increasing test, right? Increasing, decreasing test. So I'm going to take one more derivative. The second derivative here, what's that? Second derivative is positive, f prime is increasing. So we have the next one. The second derivative, positive, f prime is increasing. We have this kind of result. So another one, this is concave downward. The graph is concave downward. Why? You can choose this point. You can draw tangent line. So like this, the f of x is, this is f of x. F of x is below the tangent line. Exactly. F is rise below of each tangent line, concave downward. So like this. So what happens? F prime of x here. You can choose this point. F prime of x is what? This is slope tangent line is f prime of x is, I think, like 3. Here, you can draw tangent line. The f prime of x is like 1. You can choose this point. This is slope tangent line. f prime of x equals like 1 over 2, like decreasing. So what happens? X value is increasing. What happens f prime? 3, 1, 1/2, like decreasing. So we have it. F prime of x is decreasing. Graph of f is concave downward. So similarly, so we can use increasing, decreasing test. Was it decreasing? F prime of x is less than 0. What happens? Graph of f of x is decreasing. This is increasing, decreasing test. So like this. You can take derivative one more. The second derivative less than 0, f prime of x is decreasing. So we have this conclusion. The second derivative of x is, that is, the second derivative is just less than 0. The f prime of x is decreasing. So we have this result. So we have one conclusion. How can you check graph is concave upward or downward? We can use second derivative. Second derivative is positive number. What's that? Graph of f is concave up. The second derivative is less than 0. The graph of f is concave downward. This is like a whole idea. So we have concavity tested. The second derivative is positive. The graph of f is concave upward on I. So if second derivative is less than 0 for all x in interval I, then the graph of f is concave downward on interval I. This is called concavity testing. So one more definition. A point P on a curve y equals f of x is called an inflection point. If f is continuous there and the curve changes from concave upward to concave downward, or from concave downward to concave upward at point P, that we call inflection point. This is like inflection point. This is like a definition. So, I'm gonna give one example here. What's that? This graph is concave downward. The B to C concave upward, CD concave downward, concave upward, the EP concave upward, the PQ concave downward, the next one. So how many inflection points do we have? What kind of points? We have concave down to up. The concavity changes at B. This is inflection point. Concave up to down at C. The C is inflection point. Concave down to up, concavity changed at the inflection point. The concavity changed up to down at P, inflection point. We have the 4 inflection point. So one more. So what is the second derivative at B? Do you know what is one? Here you can take second derivative. What's that? Positive? No. Here, this is like a graph of f. I can draw f prime. What is like f prime? You can draw the here f prime of x here. This is like B. So what happens? So here, slope is 0. So we have it. This is the 0. What is this point? Slope is like negative. So going down here. From here, slope is negative again. Here, negative and 0 again. Here, 0. Graph is going up. So like this. So yeah, this is f prime of x is this graph. you can draw second derivative. The second derivative at B is, yes, 0. This is 0. The second derivative equal to 0 at inflection point. This is possible. How about E here? Oh no, P, D, sorry, D. What is f prime of x? This is like a cusp. F prime of D does not exist. Automatically, the second derivative at D also does not exist. What's that? Second derivative at t does not exist. You got it? Was it like a property of inflection point? The second derivative is 0 or does not exist. We know this kind of result. Here, this note, like this. The second derivative at B, C, P, 0. Second derivative at D does not exist. We have this kind of things. One more, function f is well connected, continuous function. Got it? So how can you check if the graph has an inflection point or not? This is the idea. You can check second derivative equal to 0 or does not exist. So like this one. How can you find inflection point? Step 1, second derivative equal to 0 or does not exist. Step 2, the second derivative changes from positive to negative or from negative to positive. So what does it mean? Concave up or down. The next, the function f is continuous. This is like a whole idea for checking inflection point. In this case, C f of C is inflection point. Does it make sense? Here, the f prime C is 0 or does not exist. Next, and plot. You can check second derivative here. Positive to negative. What does it mean? Positive to negative. What happens if graph of f? Concave up. Negative, concave down. Concavity changed from up to down. The C and f of C is inflection point. This is the idea. Similarly, the C is here. The second derivative is negative to positive. What's that? The graph of f is concave down. Graph of f is concave up. Concavity changed at C. The C and f of C is inflection point. This is like a whole idea for finding inflection points. Like this. So next one. I'm gonna give the one more method for finding the local maximum, local minimum. That we call second derivative test. So suppose the second derivative of f is continuous at C. The first one, f prime of C equal to 0. Second derivative f of C is greater than 0. So what happens? So this is a result. F has a local minimum at C. F prime of C equal to 0. The second derivative at C is less than 0. Then F has a local maximum at C. So this makes sense. I can draw the graph. This is very clear. The graph is like this. This one. You can choose point C here. What is f prime of C? Yes, 0. Exactly. Horizontal tangent line. What is second derivative at C? What is second derivative at C? So let me see. So this one is concave up or down here. Concave up or down, this portion. Concave down, concave down. Was it like a second derivative of a concave down? Less than 0. That's it. This is true. The 0, second derivative less than 0, yes. Local maximum at C. Here. This is like D. What is F prime of D? Yup, 0 again. This is horizontal tangent line. What is second derivative at D? A positive number because this portion is concave up. So what's it like second derivative of the concave up things? This is positive. So that's it. The first derivative is 0. Second derivative is a positive number. F has local minimum at C. This is the whole idea. So we have the like this. We have it. The next one. I'm going to give the example. Suppose that the second derivative of x equals x plus 3 square, x minus 3 times, x minus 7 cubed. Find the intervals of concavity and inflection point. So similar. You can find second derivative equal to 0 or does not exist. The first one. The second derivative equal to 0, what's that? The second derivative equal to 0, this one equal to 0, automatically this whole thing equal to 0. So like this. You can solve. X is here. X plus 3 equal to 0, x is negative 3. X minus 3 equal to 0, x is 3. X minus 7 equal to 0, x is 7. We have negative 3, 3, and 7. We have these three numbers. The second derivative does not exist. We don't have a denominator. The second derivative of x always exists, but we don't have a second part. The next, you just only plot. Here, you can plot negative 3, 3, 7. The next, you can check second derivative is positive or negative. I can choose test number. Could you choose test number less than negative 3? Could you choose? Okay, good. Minus 4. You plug minus 4 into here. Minus 4, minus 4, and minus 4. So this is even power, always a positive number. The negative 4 minus 3 is negative. The negative 4 minus 7 is like negative. So we have it. The negative times negative is positive. So like this. You can choose test number. I can choose 0. You plug 0 into x. What's that? You plug 0 into x, 0, 0, and 0. So we have 0 plus 3 square positive, 0 minus 3 is negative, 0 minus 7 is negative. This is exactly negative times negative is positive. So like this, you choose, I can choose 4. The 4 into here, 4, 4, 4. The positive, 4 minus 3 is positive. 4 minus 7 is negative. So like negative. The last one, choose 8. Same, you can plug into x. Here, you can plug 8, 8, and 8. So what's that? 8 plus 3 is positive, 8 minus 3 is positive, 8 minus 7 is also positive. All positive numbers, positive. What's the graph of f? The first one, concave, up. Second one, concave, up. Third one, concave, down. Concave, up. This is like a whole idea, the whole idea. So we have this graph. So concave upward on here. This interval, and this interval. So negative infinity to minus 3, so negative 3 to 3, 7 to infinity. Concave down on only one interval here, 3 to 7. So like this. We have two inflection points. Concavity changed at 3. Concavity changed. Concavity changed at 7 here. So we have two inflection points. Just like a whole idea for finding answer of this question. So far so good. So far, do you have any questions so far? Okay. So if you don't have any more question, we are going to another example here. The f of x equals x to the 4 negative 6x squared plus 10 is given. The first problem, find the intervals on which f is increasing. Second one, find the intervals on which f is decreasing. Third one, find the local maximum values and the local minimum values of f. The next one, find the intervals on which the graph of f is concave upward. The next one, find the intervals on which the graph of f is concave downward. The sixth one, find all inflection points of f. The last one, sketch the graph of f. This is like the whole problem. The first one, how can you check the increasing, decreasing, local maximum, and local minimum? How can you calculate? We need first derivative. F prime of x equals x to the 4 negative 6x squared plus 10 prime. So you can use a power rule. X to the 4 prime is exactly 4x cubed. Negative 6 times x squared prime is 2x. The 10 prime is 0. So we have 4x cubed negative 12x. So one more, we have a common factor for x, factor for x. X squared negative 3. So we have this equation like this. So next, you can calculate f prime of x equal to 0 or f prime of x does not exist. F prime of x equal to 0, exactly this one equal to 0. This one equal to 0, so we have it. So x equal to 0 is the first one. This is equal to 0. The second one equal to 0. We have two equations. X squared equals 3. What is x? Yes, plus or minus square root of 3. So we have the 3x values. X is here, 0. The plus or minus root 3. We have the three numbers. The first derivative does not exist, impossible, because this is always well defined. So you have to plot, right? You have to plot this one. How can you plot? So like this. You can draw plot here, negative root 3. 0, root 3. So like this. You can choose test number. You can check f prime. You can choose number, the less than negative root 3. So which number do you want to choose? So this number is the less than negative root 3. Minus 2 is right, not 2. The negative 2, you can choose it. Yep. You can choose minus 2. You plug into here. The negative 2 and negative 2. The 4 times negative 2 is negative. The negative 2 squared is 4. The 4 minus 3 is positive. The negative times positive is like negative. You can choose this point. I choose a -1. You plug into x, -1, -1. 4 times -1 is negative. The -1 square is, what's the -1 square? The 1. 1 minus 3 is negative. So this is negative. This is negative. This is negative. The negative and negative is positive. Here, positive. You can choose 1. You plug into here, +1, +1. 4 times 1 is positive. 1 minus 3 is negative. This is like negative. I can choose 2. You plug into x, 2 and 2. 4 times 2 is positive. 2 squared equals 4. The 4 minus 3 is positive. We have positive. What's it like a graph of f? Graph of f is here. This case is decreasing. Here, increasing, decreasing, and increasing. So this is answer. Was it like interval on which f is increasing? Here, negative √3 to 1, the √3 to the infinity. So we have negative √3 to 0, and the √3 infinity. The next one, the decreasing, which one? Here, graph is decreasing, this is decreasing, this is also decreasing. Decreasing is this interval. Minus infinity to negative √3, minus infinity to minus √3, and one more here, 0 to √3. This is like the decreasing. So it's good. So this is the whole idea. So do we have a local maximum, local minimum? A local here. Was it like -√3? Local maximum or local minimum? -√3. Local minimum. Graph is decreasing and increasing. Local minimum. Was it like 0? Local maximum. Graph is increasing, decreasing. Was it √3? Minimum again. Decreasing, increasing. So like this. We are going back to here. So like this. We have it. Here, local maximum and -√3. Local minimum. Here, graph is increasing and decreasing, local maximum. So here, local minimum again. We have these values. So like this. That's good. So we have this result right now. So you can calculate f of 0, like local maximum. What's it like f of x? The f of x is from the first part, x to the power 4, the negative 6x square plus 10. You can plug 0 into x. So we have 0 to the 4 minus 6 times 0 square plus 10. So we have 10. The 10 is the local maximum here, local maximum. So similarly, you can plug -√3 into f of x. The negative √3 to the 4 minus 6 times -√3 square. What is negative √3 to the power 4? So what's that? Do you know this one? What's that? -√3 to the power 4. What's -√3 to the power 4? Yeah, 3 square. This is right. So this is same to the 4 is like even power, exactly the √3 to the power 4. The √3 power 4 is √3 square and square. The next one, the √3 square is 3 square. 3 square is 9. We have, this is 9. The -√3 square equals 4. So we, 3 like this. So we have 1. Is right. 9 minus 6 times 3 is 18 plus 10. So we have 1. We have it, local minimum. The root 3 to the 4 minus 6 times the root 3 square plus 10 is very similar to the previous one, it's 1, local minimum. We have 2 local minima, 1 local maximum, so like this. Next, we think about second derivative. How can you find the second derivative? We use the first derivative. The first derivative is from the problem 1, 2, 3, 4, 1, 2, 3. So we have 4x cubed minus 12x squared. So we have, what's the second derivative? Second derivative is the derivative of the first derivative, minus 12x squared prime. So like this. Not x squared, sorry. This is only 12x. Only 12x. Erase here. No. 12x. So like this. So what's that? This is same to the 4 times x cubed prime is 3x squared. The 12x prime is just 12. So we have 12x squared minus 12. You factor out 12x squared minus 1. You can factor more. 12 times, what's the factor? What's the factor? How can you factor? It's good, you're right. So x plus 1 times x minus 1. So like this, you can factor. So like this. So next one, you can check concave up or down. How can you check concave up or down? The second derivative positive or second derivative does not exist. We can check these kind of things. So second derivative equal to 0, what's that? This is second derivative equal to 0, exactly. The factor form equal to 0. So we have it. So what's that? So this one equal to 0 or this one equal to 0. You're right. Yes, thank you. This x is the minus 1 and 1. So we have 2 numbers. The second derivative does not exist. Impossible. This second derivative is always well defined. We don't have it. Second derivative does not exist. The next one, you can draw like this one. You can draw the line. You plot point minus 1 and 1. You can check the second derivative is positive or negative. You can choose point here, negative 2. You plug negative 2 into x. Negative 2, negative 2. What's that? Negative 2 plus 1 is minus 1. The negative 2 minus 1 is negative 3. The negative was like a second derivative, positive. I can choose 0. You plug into here, 0 and 0. 0 plus 1 is positive. 0 minus 1 is negative. This is negative. You can choose 2. You plug 2 into x. 2 into x. Positive, positive. We have positive 1. This is like whole idea. So what's it like f? The positive second derivative, concave, up. The negative second derivative, concave, down. The positive one is concave, up. So we have this kind of things. So like this. So we have concave up on this interval. Minus infinity to minus 1. 1 to infinity, 2 intervals. Concave downward at middle one. Here, just to middle one. Here, middle one. We have minus 1 to 1. Do we have inflection points? Do we have inflection points? Yes? Okay. What's the inflection point? Yeah, minus 1 and 1. The concave up to down change it. Here, concave down to up here, 1. The one more, the function f is like a polynomial, always continuous. So we have inflection point. You can calculate f of minus 1. So what's it like f of x? The f of x is, so from the previous one, x to the 4, negative 6x squared plus 10. This is like f of x. F of minus 1 is plug minus 1 to 4, 1 to x, minus 6 times minus 1 square plus 10. The minus 1 to 4 is 1. Minus 1 square is 1. 1 times negative 6 is negative 6 plus 10. The 11 minus 6 is 5. So we have this one. The what's f of 1? Similar. 1 to 4, negative 6 times 1 square plus 10. 1 negative 6 plus 10 is 5 again. We have 2 points. The minus 1, 5 is 1 inflection point. X component to 1, Y component to 5 is second inflection point. Okay, the next, you can combine this graph and the previous one. So you can combine the both of them. So we have like this. The f of x is like decreasing from minus infinity to negative root 3 from the previous one. The root 3 to 0 increasing, 0 to root 3 decreasing, root 3 to infinity increasing. What's it concave up and down? The 0 to minus 1 concave up, minus 1 to 1 concave down, 1 to infinity concave up. So we have more. We have a local maximum at 0, 10, local minimum at negative root 3, 1, local minimum at the root 3, 1. We have 2 inflection points, minus 1, 5, 1, 5 from the previous result. The next, we can draw the graph by using these whole things. The first one, you have to plot. You have to plot the point. The first one, 0, 10. You can plot local maximum, 0, 10. Here, 0, 10. The next, you plot the minus the root 31. The minus the root 31 is, I can plot here, the negative, the root 31. This point is exactly the negative, the root 3, 1. Another one, 1 root 3. So here, sorry, root 31. This point is exactly the root 31. So you can plot minus 1, 5. Here, minus 1, 5 is here. This is negative 1, 5. Another one, 1, 5. 1, 5 is here. The 1, 5. So here, was it like till here? Graph is decreasing concave up. Decreasing concave up. Graph is decreasing concave up. So like this. Minus root 3 and the minus 1. Graph is increasing concave up. Like increasing concave up. Here. The next, the minus 1 to 0. Increasing concave down. Concavity change it. This is inflection point. Graph is like this. Another one, 0 to 1, decreasing concave down. Graph is decreasing concave down. So like this. The 1 to root 3 here, decreasing concave up. So we have decreasing concave up. The last one, the greater than root 3, this case is increasing concave up. Like graph is increasing concave up. So that's it. This is the whole idea for sketching the graph. Like this. So it's good. This is the whole idea for sketching the graph. I want to give one more example here. The sketch a possible graph of f that satisfies the following conditions. Here, f of 0 equal to 0, f of 2 equal to 3. f of 4 equals 6, f prime of 0 equals f prime of 4 equals 0. The next one is the first derivative is greater than 0 for x is between 0 and 4. F prime of x is less than 0 for x is less than 0, x is greater than 4. The second derivative, x is greater than 0 for x is less than 2. The second derivative is less than 0 for x is greater than 2. So, how can you sketch the graph by using these informations, these conditions? The first one, you can think about here. F prime of 0 equals f prime of 4 equal to 0. So we have this one. So what does it mean? The first derivative equal to 0, the 0 and 4. The 0 and 4 is the critical numbers. The critical numbers. So we have this kind of things. The next, you can just sketch the increasing and decreasing by using second condition. The second condition is here. So what's it like a graph? The next one. So we have 0 and 4. You can plot 0 and 4. The x is between 0 and 4. What's it like f prime? F prime is 0 and 4 is positive. So we have positive. The x is less than 0. The first derivative is negative. X is greater than 4. The first derivative is negative. What's it like a graph of f? Graph of f is decreasing, increasing, and decreasing. This is the idea. The next, we can think about second derivative. What's it like a second derivative? Only use 1.2 here, the middle one. Here, 2. So less than 2, second derivative is positive. The second derivative is positive here. The x is greater than 2. Second derivative is less than 0, like negative. What's it like a function f? Concave up. Here, concave down. This is like a whole idea. You can sketch it. The graph is like this. Next, sketch the graph. Here, you can sketch the graph. This one, you can plot point. f0 is 0. 0, 0. f of 2 equals 3. So here, 1, 2, 1, 2, 3. This point. 4 has 6. 3, 4, 4, 5, 6. So we have this point. You can connect this point. So next, what's the graph? The x is less than 0. Graph is decreasing, concave. Graph is what? Decreasing, concave. So like this. So 0 to 2. 0 to 2 here. Increasing, concave. Graph is increasing, concave. 2 to 4. 2 to 4 here. Increasing, concavity changed. Concave down. This inflection point, concavity changed. So like this. The 4 to infinity, decreasing, concave down. Graph is decreasing, concave down. So like this. So that's it. This is the whole idea for sketching the graph. So like this. Okay, this is like the one example. So I want to give the one more example here. So here, the graph of f, the derivative of f of a continuous function f is shown. So like this. This is f prime of x. You can define intervals. The which interval is increasing, on which interval is decreasing. The local maximum at x value. The find the x values at local minimum. You can check a concave up or down. You can find inflection points at x. This is like equation. As I said before, this is not graph of f, the graph of f prime of x. F prime of x. The first, we think about decreasing, increasing, local maximum, local minimum first. So here, this graph is given. So how can you check increasing or decreasing? So how can you know? F prime of x is given. How can you know graph of f is increasing or decreasing? How can you know increasing, decreasing? Do you have any idea from the f prime of x? How can you check if graph of f is increasing or decreasing? How can you know these kind of things? You're right. The first derivative is positive, graph of f is increasing. The first derivative is negative, the f is decreasing. This is the idea. It's good. You're right. F prime of x is positive, f of x is increasing, f prime of x is less than 0, f of x is decreasing. We can use this result. So one more. How can you check the local maximum, local minimum? How can you know the local maximum, local minimum? How can you know these kind of things? That's right. The f prime of x is changed from positive to negative, negative to positive. The one more, the f prime of x equal to 0 or does not exist. Is right? Does not exist. This is exactly the answer. So here, either f prime of c equal to 0 or f prime of c does not exist. So check this kind of things. F prime is changed from positive to negative, f of c is local maximum. The f prime changed from negative to positive, f of c is local minimum. This is whole idea. That's right. So let me see. First one, increasing. The increasing and decreasing. On intervals. The first one, here, was it like f prime of x? F prime of x is below x-axis, like negative. So we have decreasing. So minus infinity to 1. What is 1 to 3? What's 1 to 3? Increasing or decreasing? 1 to 3. Yes. So here, graph is above x-axis, f prime is positive. So increasing 1 to 3. What's 3 to 5? Yes, increasing again because f prime is positive. 3 to 5. Was it like a 5 to 6? Increasing or decreasing? This is like decreasing, is right? Below x-axis, decreasing. 5 and 6. Was it like a 6 to 7? Yeah, this is above x-axis, increasing. Was it 7 to 9? This is below x-axis, decreasing. 9 to 10, above x-axis, increasing. The 10 to 11, this is above x-axis, increasing. The last one, 11 to infinity here, below x-axis, decreasing. Yeah, this is the whole idea. The next one, the local maximum, local minimum. local maximum, local minimum. So what's that? What's the local maximum? Two, four. Really be careful. This is not f of x. This is what? F prime of x, not f of x, f prime of x. The local minimum is here. When do you have the local minimum, local maximum? Local maximum is sign changed from positive to negative. The local minimum, sign changed to negative to positive. This is the idea. From here, what is the sign? Here, f prime of 1 equal to 0. Exactly this one. F prime 1 equal to 0. So sign changed from negative to positive. Graph is decreasing and increasing. We have local minimum at 1. So like this. Yep. Was it like 3? This is also f prime of 3 equal to 0. So here, this one. So local maximum or local minimum at 3. 1 neither. The local maximum, local minimum, 1 neither, because sign doesn't change here. Positive and positive. Sign doesn't change. Positive, positive, nothing. What's 5? This is f prime of 5 equal to 0. Exactly this one. What happens to sign? Yes. Positive to negative. Sign changes. Positive to negative. Graph is increasing and decreasing. Local maximum at 5. The next two. What happened to 6? What's 6? Yeah, f prime of 6, what's that? We don't have a function value, does not exist. This is a local maximum, local minimum, or neither. Local maximum, local minimum, or neither at 6. What do you think? The minimum? So here, was it like exact conditions? Here, function f is what? Continuous function. This is a very important thing. Function f is continuous function, well connected. So what happens? So here f prime 6 does not exist. What is it like less than 6? Graph is decreasing. The greater than 6 increasing. The graph is, you can just sketch the graph is like one. The decreasing and increasing. We have cusp. We have cusp at 6, local minimum at 6. This is continuous. Function f is continuous. F prime is discontinuous, but the problem said function f is continuous. In this case, we have cusp at 6. We have local minimum. Was it like 7? F prime of 7 equal to 0. The sign change from positive to negative. Yes. Increasing and decreasing at 7, local maximum. Was it like 9? F prime of 9 equal to 0 again. The graph is decreasing, increasing. The negative to positive here, negative to positive, local minimum. The graph is the decreasing and increasing at 9, local minimum. How about the 10? What's F prime of 10? F prime of 10, what's that? Does not exist. Function value does not exist. Here, local maximum, local minimum, or neither at 10. Yeah, neither, because sign doesn't change. Positive to positive, nothing. Was it like 11? The f prime of 11 equal to 0. The 0. So sign changed from positive to negative. Here, positive to negative, yes, local maximum at 11. This is the whole idea for finding answer of these questions. So like this. The next, concavity. How can check concavity? So we can use previous result. This is a very important thing. the f prime of x is increasing, the f of x is concave upward. F prime of x is decreasing, f of x is concave downward. We can use this result. Another one. How can you find inflection point here? Note, the second derivative s equal to 0 or does not exist. So concavity changed SC. One more. F is continuous SC. C f of c inflection point. So don't worry about function f is continuous SC because so what's it like conditions here? Function f is what? Yeah, continuous function. So don't worry about the last conditions. So here, like this. So we think about concave upward or downward. Concave upward on interval, the concave downward on the interval. Fine. So what's that? F prime is increasing, concave upward. Here, graph is increasing from minus infinity to 2. This is increasing graph, concave upward. We have minus infinity to 2. Here, decreasing, concave down. Here, 2 to 3, graph is decreasing. 2 to 3, graph is decreasing, concave downward. 2 to 3. The 3 to 4, increasing again, concave up. 3 to 4. The 4 to 6, graph is decreasing, concave down. Oh, not here. Concave down. Four to 6. Do we have it? So another one. What is 6 to 8? What's that? What is portion? What's 6 to 8? Yes, decreasing, concave down, 6 to 8. What's 8 to 10? Graph is increasing, yes, concave up, 8 to 10. The next one, 10 to infinity. 10 to infinity, graph is just decreasing, concave down. Infinity. The next one, you can find inflection point. Points at x. Was it like inflection point? Concavity changed, second derivative equal to 0, what does not exist. Here, at 2, f prime of x, you can draw tangent line. Was it like a second derivative at 2? This is equal to 0. Is right? Second derivative equal to 0. Another one. F prime of x is increasing and decreasing. What does it mean? Increasing is concave upward, decreasing is concave downward. Concavity changes at 2. Yes, inflection point at 2. What's the 3? Same. The second derivative is 0. So the f prime is decreasing and increasing. Concave down to up. So down to up, yes, inflection point. What's it 4? This is inflection point at 4? Yes, same. The second derivative at 4, we have a horizontal tangent line equal to 0. So here, f prime is increasing and decreasing. Here, concave up to down. Concave changes at 4. The next one was 6. The here, f prime of x does not exist automatically. The second derivative at 6 does not exist. Concave concavity change it at 6? What do you think? Concavity change it? The 6 is inflection point 1. The 6 is inflection point. So what do you think? The 6 is inflection point? No, because here, decreasing concave down, yes. Decreasing concave down. Concavity doesn't change at 6, no. Was it like 8? Here, we have the second derivative at 8 is also 0. Here, decreasing concave down, increasing concave up. Concavity change it at 8. We have 8, so like this. Was it like 10? The second derivative at 10, this is like a vertical asymptote. Automatically, second derivative does not exist here. At 10, inflection point 1 knot. This inflection point 1 knot. Inflection point, yes. Graph is increasing on the left-hand side, concave up. Graph is decreasing on the right-hand side, concave down. Concavity changed from up to down. Yes, this is inflection point. We have 10. Okay, this is like a whole idea for solving this last problem by using this idea. Okay, so this is all for today's lecture. So if you have any question, could you write your question on the chatting board? So if you don't have any question, you can leave live session. No question? Okay, good. Okay, you're welcome. Yeah, see you later. So thank you for attending my class. So thank you. Okay, goodbye. Bye.